Hey guys, this is Matt, and so today we're going to be talking about the Vigenere Cipher. Now, the Vigenere Cipher is a little different from what we do normally use, as you can see from this giant table we've got up here. Um, and this whole thing is part of the series Cryptography on Simple Ciphers, where we actually look at the mathematics behind each of these simple ciphers. So just a little bit of history on the Vigenere cipher. It was back in the 16th century that Mr. Vigenere, he actually developed this and came up with it. And it was known as the unbreakable cipher because it was very different from what they had normally used. And so they didn't know what to do with it. So they kept using the repeated key deceptive. And that's one difference with it. It works like a Caesar cipher, but it's actually part of a polyalphabetic cipher. So basically with this is it uses a key to actually help encrypt and decrypt each the ciphertext. So you can see that we've chosen the original message crypto, and we've got our keyword here. Now, in 1861, Frederick Kaczynski, I really hope I said that right, published the solution to this, and that ended ended this being called the unbreakable cipher because obviously he had broken it. So I will be posting a link to the history on this. And so going through, I had seen a video on by Brian on the Vigenere cipher, but instead of having a keyword, he broke it using a frequency tool, and I will be posting a video to that as well. We will be using obviously our keyword, and we will have it. I will deal with the frequency tool a bit later within the series, but for right now, we're doing it and showing the math behind it. So, one more source, Oxford Math Center does a great job actually showing the back end of the math behind this. So, I will post a link to that as well. The looking on the screen, we've got this is my Excel spreadsheet that I've actually got it laid out. This is what your table looks like. And these are the alpha decimals. Basically, what I did was I took the ASCII value and subtracted 65 from it. So now we get these, and then when we go to actually convert it back, we just simply add 65, and we can see it come up. And so I've got it, the actual math behind it is C, which is ciphertext, or your cipher, character at this position, so this would be our character, equals the plain text plus the key, mod 26. Now, to calculate our cipher number, we've gone through and we're taking the mod of E31 plus E32, which would be our plain text I, and then our key J, which would basically be just those positions. So we're going to be able to see how this actually works to encrypt and then decrypt it. So a, a Vigenere cipher is different also because we can take it and we can look and say we have our message here. We can do this manually or by hand. So you've got your the actual text here, and then your keyword will be up here. So you've got C, so you can take it, and then you go over to M, which is for your keyword up here, and then we can simply take that and we can actually start to go through and find the ciphertext for this. So R. Now we go off the yellow. We don't go off of these rows, we go off the yellow. So R and then A. That's going to be easy right there. Then you have Y. And then T. Then we can go through, we'll do one more. Let's see, we have YP. There we go. And then H, here we go. So W. All right, so we can do this. Obviously, for our benefit, we are going to actually look at the math behind it and why that's there, why this actually works, and so on. So, which I'll leave those marks so we can actually double check it. So we're going to go through, and I've already taken this and converted it to our ints, so we can actually go through and double and check and look and actually just plug them in. So our first one is 2 for C, and then we have 12 for our keyed. So O, which is what we got up there. All right, and then for our cipher number, it's 14. All right, now we have 17 and 0. R, and then we had 17 for the so just keep in mind this is it's your the plain text integer plus the key integer and then mod 26. So now we have so OR, let's do 24 and 19. All right. So 15 and then 7. Now we have 19, 12, the F, be 5. And actually, I believe I missed 22. That was my bad. I didn't put that down. And then we have, for our last one, 14 and 0. And that would be 14, which would give us an O. So, we can see how it has converted it to this right here. So, ORRWF is O. And we've got 14, 17, 17, 22, 5, and 14. So how do we get it back from this to that? Because this doesn't make any sense. And I did forget to mention if your keyword, which is why it's called a repeated key, you pick a keyword, and if the key does not match the length of your original message, then you simply repeat it until you have met the length of the message. So we have MATH, that's 4 plus 2, so MA is going to be 6, which will match that. So to decrypt it, we go through and we subtract them. We take the ciphertext, so we've got 14, and then we have 12 for the keyword numbers, so we have C. And no, we don't want to spell it out already, although we are correct, but we still have to figure it out. So now we have R. Y. We're only at Y. All right. Then 22 and then 7 P. Which I guess that was my fault for sticking them right in a line, but it's okay. And then, so 5 and then 12 T. And we're not there yet. Here we go. 14 and then 0. And there's our O. So we have seen it go from going through the encryption process by adding the plain text plus the key ints, so convert them to ints, then you add them, then take the mod 26 because we got 26 letters in the alphabet, and then from there, then we go through. It's, if you're looking to hold with the math, then it's good to actually write them out as, so you can keep up with what you're doing. And if the keyword does not meet the length of the message, then simply just start repeating the keyword until the message length is met. And then here is our cipher text right here. So we can take that, and here is our cipher numbers, and here is our decrypted text, which does match the original message. So thank you very much for watching. I really do appreciate it. If you have any questions about this, that's fine. Just feel free to let me know or drop it in the comments below. If you need help breaking any ciphers that you need to actually study the math behind it, let me know, and I'll be happy to help where I can. I will be providing these links in the details below. So thank you guys very much for watching. There will be quite a few more videos on cryptography on simple cipher, and we're going to be going over quite a few more. So thank you guys very much for your time. I really do appreciate it, and I hope that this has been beneficial to you. So thank you.